All right, this is a calculus video about derivatives. And here's an example of the power rule. And the power rule is how you take the first derivative. So f of x is this equation, and then this f of prime or f of little floating 1 of x, that means the derivative. So how do you take the derivative? You multiply the coefficient times the exponent. So that's what this is, 2 times 2. And then you decrease the exponent by 1. So that's what that is, 2 minus 1. And then you do the same thing here. Wherever you have an x, you do that. The exponent, there's nothing there, so it's a 1. And there's nothing in front of the x. The coefficient is also a 1, so that's where the 1 times 1 comes in. And then 1 minus 0. 1 minus, oops, not 1 minus 0. 1 minus 1. You take 1 away from the exponent. So 1 minus 1 is 0. Anything to the 0 power is just 1. So really, when you take the derivative of x, it just becomes 1. Because the exponent times the coefficient, 1 times 1 is 1, and the x goes away. Because when you take away 1 from the exponent 1, it's a 0, and x to the 0 is just 1. So that's a 1. Over here, you got 2 times 2 is 4, and 2 minus 1 is 1, so x to the first power. So there you go. There's your derivative of 2x squared plus x. It's 4x plus 1. And then if you want to evaluate that derivative, let's say at the value of 1, then you just substitute a 1 in for x, and you get 4 times 1 is 1 plus 1 is 5. So the value of the derivative of this f of x function at 1 is 5. That's the easy way to do it. I'm going to show you a hard way to do it in a minute, like one of my students is being asked to do for some reason. Here's another example, 4x squared plus 2x, evaluated at 2. Well, you take the derivative, so 4 times 2 is 8. So the derivative of 4x squared is 8x. You take the derivative of 2x, and that's just 2. 2 times 1 is 2. And then you evaluate it at 2. So 8 times 2 is 16. 16 plus 2 is 18. Again, pretty simple for taking a derivative and evaluating it at a certain number. Now, there's harder ways to do this. So I'm going to show you a more difficult way now. The same example, 2x squared plus x. This is using a limit. This function right here, f of x minus f of a all over x minus a, will eventually get you to the same answer, 5. It's just way more complicated. But let's go through it here. So off to the side here, I have, this is our problem here, 2x squared plus x, and if you evaluate that at 1, you get 1 squared is 1, 2 times 1 is 2, 2 plus 1 is 3. That's what this is. That's what the f of a is. So when they say f of a here in this formula, you just take whatever they give you for a, which in this case was 1, and you substitute it into your equation, do the math, and in this case we got 3. So minus f of a is 3. F of x, that's just the equation that they gave you, so that's 2x squared plus x, so that's where that comes from. And the denominator is just x minus whatever a is, in this case 1, so x minus 1. Now the next few lines I'm going to forget about the denominator for now, and we're just going to work on the numerator. So on the numerator, here's where it gets crazy, and I probably would have never dreamt of this on my own, but this is the only explanation I can think of. This is a 1x. 1 is the same thing as 3 minus 2. Now, using that logic, 1 is the same thing as 7 minus 6 and 8 minus 7, so how they came up with 3 minus 2 right here, but that's basically what they did. They have a positive 3x and a negative 2x instead of a positive x. The 2x squared is still there, the minus 3 is still there. They just got rid of the positive x and made it a 3 minus 2 basically. And the reason they did that is so that you could factor out a 2x from these two terms right here. Take a 2x out of here and you're left with an x. Take a 2x out of here and you're just left with 1. So you factor out a 2x, which is right here, and you're left with x minus 1. And then in these two terms, you could factor out a 3, and you're also left with x minus 1. So then you combine the 2x plus the 3, and that's this parenthesis, and the x minus 1 is just a single x minus 1. It's basically factoring out again. So like, you're basically factoring out a x minus 1 from this term, and you're left with a 2x, and you're factoring out a x minus 1 in this term, and you're left with a 3. And then these are kind of written in reverse order. Like, it'd probably make more sense to write the x minus 1 first, because that's what you pulled out of each of these terms. But regardless, that's where this comes from, is this somehow magical conversion from a single positive x to a negative 2 and a positive 3. And then your x minus 1 in the denominator, that cancels out with the x minus 1 in the numerator, and you're just left with 2x plus 3. And then they substitute in the 1 for the x, and you get 5. Just like we got here, which was way, way, way easier. So unless they specifically demand that you do it this way, which I don't know how they can do that because it's a multiple choice test. So the answer is 5 is going to be there, and however you can get to 5, get there. So I recommend doing it the easy way. Someday you might have to do it this way when problems get way more complicated, but for now you shouldn't have to. You could probably just do it the easy way. All right, there's another way to find a derivative when you evaluate it, and this is the definition of a derivative. So this is the formula for that, which looks even more complicated. And it is, but we're still going to end up with 18, just like we did the easy way. So this is your formula. So you start with that basic formula, and you plug in the number that they give you for a. So in this particular problem, it was 4x squared plus 2x, and they wanted you to evaluate it at 2. So you put a 2 in for the a. So that's where this first line comes from. And again, I'm forgetting about the denominator h for now. We're just going to work with the numerator, and eventually the denominator will come back into play at the end. But for now, we're just working with the numerator. So I put the 2 in for a, and now this is where it gets a little bit confusing, is that this f of 2h, 2 plus h, is like the f of x. So basically over here, wherever you see an x, we're going to substitute in a 2 plus h. So instead of 4 times x squared, it's 4 times 2 plus h squared. So these x's, both these x's right here, are going to become 2 plus h. So this is 4 times 2 plus h squared, and this is 2 times 2 plus h. And then we have minus the f of 2. So what is f of 2? You got to put a 2 into these x's. So that's what this is right here. So you put a 2 in for that x. 2 squared is 4. 4 times 4 is 16. Put a 2 in for this x. 2 times 2 is 4. 16 plus 4 is 20. So that's where this 20 comes from, is f of 2 getting put in here. All right, now you do your FOIL. You do 2 plus h times 2 plus h, and it gives you this, 4 plus 4h plus h squared. And you distribute the 4 through to get 4 times 4 is 16. Over here, we distributed the 2 through. 2 times 2 is 4. 2 times h is 2h. Now we have all these terms, and we're going to combine all these like terms here. So luckily, all the constants, the numbers by themselves, disappear, because 16 plus 4 is 20, minus 20 is 0. So our constants are gone. We only have a single h squared term, so that stays the same. And then our h's, we have 16 and we have 2, so that becomes 18h. And now we can factor out an h from this, and we're left with an h coming out of both terms. We're left with a 4h here and an 18 there. And now the denominator of an h comes back into play because it cancels out that h we just factored out. And that's why we're left with just a 4h plus 18. And then you evaluate this as if the limit is approaching 0. So now we're going to substitute in a 0 for h, and 4 times 0 is 0, and we're just left with 18. Ridiculously more complicated than the original way of this. See how short that was to get to 18? You just take the derivative and you plug in a 2 and you get 18. So that's my tip to you on these problems, is just take the derivative and plug in the number that they give you, and it should be a lot easier.